Hello, little sponges. The universe is a vast and interesting place. It is full of stars, planets, and many other cosmic objects for us to observe and revere. I, for one, have always been interested in astronomy since I was a wee lad, although it caused me many sleepless nights thinking about asteroids, comets, and gamma ray bursts that could destroy our Earth. Indeed, any one of these could easily wipe our Earth clean, but they're an everyday occurrence across the rest of the universe, and it would take a disaster of cosmic proportions in order to destroy it. Some say it would be impossible, but that's not true. There are many ways we could shatter the engine of reality, and so today I will discuss, for my first real video, the 4 ways the universe can end. I hope most of you know that the universe is constantly expanding. It has been doing so ever since the Big Bang. It shows no signs of stopping and is only getting... However, if the force of gravity managed to overcome this expansion, it would have dire consequences for the universe at large. This event is called the Big Crunch. Simply put, the universe would start to collapse into itself from its own gravitational pull. At first, galaxies and galaxy clusters would start to ram into one another, creating super large, densely packed super galaxies, full of trillions of stars. With space getting smaller, the heat of the cosmic microwave background would compress, making the background of space hotter as a result. As the background temperature of space would get hotter, everything else would get hotter too. And it wouldn't help that stars would begin colliding into one another as space became even smaller. 500,000 years before the end, the universal temperature would reach around 3,000 degrees Kelvin. Class M stars, or red stars, would start to boil from the outside and cease to be. This would go for higher tier stars as the universe became even smaller and even hotter. Type G stars, like our Sun, would be one of the next ones to go, with Type A stars like Sirius coming afterward. 100,000 years before the end, even enormous blue hot Type O stars like UY Canis Majoris would start dissipating a hot plasma. Things would continue to get even hotter and more crowded, but atoms would still retain their forms. But by the last minute, even they would be split into pieces from the overwhelming temperatures. All black holes in the universe would consume any matter that was left and merge into each other as the Big Crunch completes. Both time and space will be ripped apart, and all that will be left would be an infinitely small, hot, dense point. Does this sound familiar? This is the same state that the universe was in before the Big Bang. Many think that this would be preceded by a new Big Bang, starting the cycle over again. This could have happened an infinite amount of times before we even existed. It may continue for the rest of eternity. This version of the Big Crunch is known as the Big Bounce, and might bring upon a new universe after this one in the far future. Thus, there is a happy ending here. Wonderful, right? However interesting the Big Crunch theory is, it's very unlikely that it will actually come to fruition. As I stated before, expansion is not stopping. It is only getting faster! While we aren't sure of the why behind it, we call the force causing this phenomenon dark energy. Again though, we have no idea how it works. One of the things we don't know is whether it increases exponentially or eventually starts to decrease or fizzle out with time. If it does constantly increase, this will lead to a big rip. Being the antithesis of the Big Crunch, the Big Rip is a scenario where the expansion of the universe eventually overcomes every other force and eventually rips space-time to pieces. The time frame for this event depends on how much dark energy increases over time. We don't even know if it increases indefinitely, let alone by how much. Thus we will use one estimate where it happens in 22 billion years. By 200 million years before the Big Rip, galaxy clusters would spin into their individual galaxies. Gravity on the scale would no longer be able to hold such large structures together thanks to the universe's expansion. By 60 million years, galaxies themselves would be ripped apart. In the last 3 months, solar systems like our own would be violently separated. Planets and stars would fly off in every direction. In the final minutes, even the planets themselves and everything on them would be torn to pieces. Finally, In the last 10 to the negative 19 seconds, even the forces keeping atoms and their particles together would be overcome by the universe's expansion. By the very end, even space and time itself would be completely ripped apart, and any space between any other space would reach infinity. Worst of all, I don't even think there would be any way for the universe to come back from this. I've not seen anything that could create a new Big Bang or any other weird ways a new universe can start in this world, which is why, in my humble opinion, I see this scenario as most depressing out of the four. So with these first two events, the universe was both squashed and ripped apart. Vacuum decay is a little more unique. For some context, scientists like to imagine the universe, its energy, and its particles as fields. There are multiple fields for different types of objects. When the field fluctuates in a certain way, it will create a certain particle. A ripple of the electromagnetic field may create an electron, bending the field one way. If it was bending the opposite way, it would create a positron, the opposite of an electron. When these two things hit each other, the ripple will cancel out, causing the destruction of both particles. These fields are the basis of reality as we know it, so they are very important. Another rule is that everything wants to get to its lowest energy state. Many use the example of a ball on top of a hill. The ball wants to roll down the hill to release its potential energy. When it gets to the bottom and the energy has been released, the ball has reached its lower energy state, or as the nerds call it, its vacuum state. But then in 1997, what does this have anything to do with the destruction of the universe? Well, maybe if you could be quiet for a moment, I would tell you. Every field of reality seems to have reached its vacuum state. We don't have to worry about these fields going haywire, except for one, the arguably most important one, the Higgs field. This field has its own particle called the Higgs boson, or the God particle as some have called it. It's a particle responsible for several different laws of physics that hold the world together. Most importantly, it gives particles their mass. It is essential that this field stays the way it is indefinitely. Any change would likely have dire consequences for the universe at large. Unfortunately, scientists' calculations have determined that the field is likely not at its true vacuum state. We would call this a false vacuum, a state of metastability. While it may want to reach a lower energy state, there is something preventing it from going further. This is presumed to be some kind of energy barrier that the boson cannot surpass. Such would require more energy than the universe has ever produced or will ever produce. So you would think we were safe, right? Of course not. Our dear universe has a workaround. There's a thing called quantum tunneling that can allow particles at random to teleport through matter and energy barriers. It isn't even the rarest thing either. It's partially responsible for photosynthesis, mutations, potentially even aging. It is an interesting phenomenon, and unfortunately for us, the Higgs boson could theoretically use this past the energy barrier, keeping it from being at its true vacuum state. The chances of this are still minute, but not zero, so it is still possible. Once it does reach the vacuum state, the new stable Higgs field will expand at the speed of light in all directions. This new Higgs field would have different laws of physics to the world we currently know. The extent of the changes is unknown. Perhaps an insignificant particle that gained more mass or something else inconsequential. If it was a small change, it could possibly allow normal matter to retain its form. Maybe even sparing life here on Earth. Now that is far more likely in this scenario. In a more extreme case, the laws of physics would more than likely be completely changed, causing dire consequences. Not only would life cease to be, but chemistry itself would become impossible. Molecules and atoms could be ripped apart of their base parts. Reality itself may cease to be within this bubble of death. It would destroy everything in its path. And because this bubble expands at light speed, who wouldn't even see it coming? One moment things are normal, the next moment you would just dissipate into the Higgs field. Indeed, this would be the end. But do not fret, my fellow big shots. Not only are the chances of this happening, especially in our lifetimes, incredibly unlikely, but it may never happen at all. Our theory of reality may work with a bunch of things, but new discoveries happen every day, and they may change the way we look at the universe. And even if we are completely correct, which we probably are not, we still don't know for certain if the Higgs field is actually metastable. In fact, some estimates put it right into stable territory. And even if all these possibilities are not true and vacuum decay could still happen, it may never even reach us. Remember that the universe is expanding very fast, faster than even light. If this new vacuum forms far enough away from us, the universe will expand faster than the vacuum can keep up with. So try not to worry about this one as much. Now, the first three endings of our universe were very violent. In one, we were crushed into an infinitely small space, in the other, we were savagely ripped to shreds. In the other, we were disintegrated. But heat death is a much more slow process. Heat death, or the Big Freeze, is a scenario where the universe eventually disintegrates into nothing but trace amounts of heat energy over an incomprehensible amount of time. This is by far the longest taking way that the universe can end, so let's get started. Let us start 100 billion to 1 trillion years from today. By this point, our sun has been dead for eons, and the Andromeda and Milky Way galaxies have been together as one for billions of years. By this point, the orbits of the other galaxies in the local group, our galaxy cluster, will decay, leading them all to merge into a singular megagalaxy rivaling the size of the largest galaxies in the universe, with potentially trillions of stars. Assuming cosmic expansion continues going faster, which is highly probable, galaxies outside our local supercluster will start to move beyond the cosmological horizon, and thus our supercluster would no longer be able to influence anywhere outside of it via gravity. This doesn't mean we couldn't still see these galaxies. The galaxies would increasingly redshift through the expansion of space, making the wavelengths wider and wider until there is nothing left to detect. This will start 150 billion years in the future, will be fully finished by 2 trillion years. Despite the isolation our galaxy now faces, star formation would continue to take place like normal for another 100 trillion years. Afterwards, however, the universe's hydrogen stocks would be completely depleted and thus no more new stars. The universe would start to go dark as stars begin to die off. Even the longest living stars like red dwarfs would cease by this point. While the occasional collision of stellar remnants like brown dwarfs may occasionally create new red dwarfs, even these will go dark eventually. This time onward is called the degenerate era, due to the only stellar mass objects remaining being stellar remnants like white dwarfs, black dwarfs, neutron stars, and black holes. By 10 to the 15 years, planets would fall out of their orbits due to gravitational decay or gravity from other stellar remnants. They would either fall into their parent objects or be flung into the abyss of space, eventually falling into something else. Same thing would happen with the remaining stellar remnants orbiting their galaxy's center, black hole, in 10 to the 16 years. Most of these stars, like their planets, would fling into the abyss. Up to 99% of them. 8 of the remaining bodies would fall into the black hole, possibly creating a quasar and by extension a bunch of light for a few thousand years. However, on these timescales, it would basically cease instantly, and in the end, nothing would come of it. For the rest of these events, we'll assume protons decay like everything else does. We aren't 100% sure whether they do, but our calculations assume that the process would take around 10 to the 36 years, the same half-life of a neutron in a nucleus. The real reason I won't talk about the alternative is because the timescales for events would basically be infinity, even more than what we are already discussing. If that disappoints you, too bad. By this point, then, half of all matter will decay into photons and leptons. By 10 to the 40 years, all normal matter will have completely dissolved into tiny weightless particles. Any civilization that somehow made it this far would finally fade, their very atoms dissipating into nothingness. The only things left now are dark matter and black holes. While the other stellar remnants have dissolved, black holes, not being made of atoms in the same way as all the others, still stubbornly cling to life. Of course, not even they will last forever. All black holes emit small amounts of energy via a process called Hawking radiation. For what I know, this happens because of virtual particles. These are literally everywhere in our universe, and they form in pairs. What normally happens is that they simply attract each other and annihilate each other. On the edge of a black hole, however, one falls into the event horizon, the other escapes, stealing a small amount of the black hole's energy in the process. Once again, though, this is still a very slow process. Black holes of 1 million solar masses will take 2 times 10 to the 64 years to phase out. Mind you, that is 2 times 10 to the 24 times longer than even matter itself lasted. There are, however, many black holes of even larger size, which take even more time. While there are none above 66 billion solar masses which have been observed yet, It's basically guaranteed that a black hole of around 100 billion solar masses is out there somewhere just due to sheer probability. A titan like this would take 2 times 10 to the 93 years to dissipate, an even more absurd timescale. However, during the collapse of superclusters many eons before this point, much of the remaining matter will have fallen into even more black holes, possibly creating titanic monstrosities of 100 trillion solar masses. This theoretical black hole would weigh 10 times our entire local group of galaxies. It would completely dwarf any stellar object before, being 31 light years in size. If we replaced our sun with this object, not only would it completely absorb the entire solar system and the Alpha Centauri system, it would envelop over 70 other stars that reside nearby. The number of years for this thing to fade is ridiculous, far larger than anything described thus far. I'll attempt to put this number in a bit of perspective, but I'm sure you'll still look at me like I'm speaking Cantonese. First, let's use a smaller but still virtually infinite number, 10 to the 100th power, or a Google. Is there anything in the real world that reaches this number? Imagine if I told you to count every atom in this universe. No, you don't have a choice in this matter. You must count every single one starting right now. There are about 10 to the 82 atoms in the universe, and if you count at a pace of 1 per second, it would take you around 3.1709792 times 10 to the 74 years of constant, never-ending counting to count them all. You'd think you're done by now, right? Wrong! You aren't even close. At all. You would have to do this mind-numbing process another 3.1536 times 10 to the 25 times. Then, and only then, will you have reached a Google. But even a Google years isn't enough for these enormous black holes to fade. In fact, we're only 0.00000000001% of the way there. Not until 10 to the 110 years have passed will these freaks of nature finally give up the ghost. With their deaths, the last objects of larger than subatomic mass have finally faded, and the universe has finally become truly dead. The only things left in this dark void are neutrinos, electrons, positrons, and photons. Any energy that is left has equally distributed itself across the empty universe, and temperatures reach close to absolute zero. Time itself becomes virtually useless as there is barely anything to measure it with. Reality is truly dead, and thus we can finally say that this is the end. Not. Despite this depressing state of the universe, it can still be brought back. Because of random quantum fluctuations and aforementioned quantum tunneling, there is a non-zero chance that a new Big Bang could occur at any time. This probability is ridiculously minuscule, but Murphy's Law states that anything that can happen will happen, given enough time. But how much time? Well, a lot. A lot. That doesn't even begin to describe it. You think that 10 to the 100th power is big? It'll take around 10 to the power of 10 to the power of 10 to the power of 56 years for the universe to bring itself back from the dead. This number is the largest number that ever numbered, at least in the universe where protons decay. The world where they don't have timescales that make even this look like a grain of sand, and I would kindly pass on that existential crisis. Either way, the universe has a backup plan. It will return, and then it'll happen again, and again, and again. The repeat ad infinitum, and due to random probability, there will be you an infinite amount of times, and thus an infinite amount of me's as well, maybe doing something different. Maybe it's you that makes this video, and I'm the viewer. Perhaps I'll be the supreme leader of an accelerationist dictatorship in Botswana. Maybe there is even a world where you go outside. With all of that said, if this is an infinite process, one question remains. Who, or what, started it? Well, I think that is a bit above my non-existent pay grade, so I will end it off here. If you want more content like this in the future, don't hold your breath. This was held for an amateur like myself to make, and I probably won't get much better. Maybe I'll make shorter videos in the future, but definitely not as long as this one. Still though, I hope you enjoy the rest of your day. This is Enderman1997, signing off.